the purpose of this next video is to just work through several examples so that you can follow through, get the feel for this. At each problem, what you should do is pause the video where you are. I'll try to give enough time for you to hit the pause button. See if you can work things out, and then we'll check to make sure you're working it accurately here. So the first thing I want to mention is this. Don't go try to work this because this problem is not well stated. There's something wrong with this problem as it's stated. Remember that we may not do this. Remember this bit about how this is not allowed? Right? I mean, this is correct, but it's not doing what we think it is. We typically would write in brackets what the derivative is being applied to. And so similarly, this doesn't really, this is very poorly written at best. In this case, it really doesn't have any meaning. We need to group. If this has more than one term, if this has more than one term, the integrand, the function, needs to be in parentheses or brackets. It needs to be grouped together somehow. So this problem now is well put. This requires the power rule, and the integral of the sum is the sum of the integrals. Notice how I'm using the word integral and antiderivative interchangeably. Find the integral, find the antiderivative. We need an antiderivative. Those words are interchangeable. They should start to become interchangeable both in your mind and in your usage. You should feel free to use integral or antiderivative in this context interchangeably. So, pause video, see if you can work this out, and then we'll check. All right, so the antiderivative. Power rule. The antiderivative of a constant is you reattach the variable. Power rule says add 1 to the exponent and divide by the exponent you just created. You have two options. You may write this as over 2, or you may write this as 1/2 times. Either of these is fine. They're interchangeable. I don't care which of those you pick. Take one and go with it. Textbooks aren't even consistent. Sometimes the text will write this, sometimes text will write this. It depends upon more personal preference than anything else. There might be a few places where one is preferred over the other, but they're both correct. All right. Let's throw in your garden variety polynomial here. So I have 9x to the 8th. And then it says minus 2x minus 6. All right. So pause, work, and then come back. All right, so let's see what we have here. The antiderivative, add 1 to the, this is power rule right along the line. The integral of a constant is you reattach the variable. So this should be easy money. So the antiderivative of 9x to the 8th. 9x to the 9th divide by 9 minus 2x to the 2nd over 2, reattach the variable, constant of integration. If all you're asked to do is find the antiderivative, that's correct. Usually I don't worry too much about simplifying, but I really hope it's not asking too much here. It's not asking too much to write this as x to the 9th minus x to the 2nd minus 6x plus the constant. So hopefully you can do that much simplification. And this is correct, but this is what you're looking for here. By the way, one way to check your result, the antiderivative of this thing is this, right? Remember when we wrote f prime for polynomials? This is the larger degree, this is the smaller degree. As you go down this list, you're losing a degree. So as you go up this list, you're gaining a degree. So which of these is lowercase f? Which of these is uppercase f? Cap f is the larger degree. This is little f. This is cap f. All right? So bear that in mind. All right, new little example here. I have the square root of x and then it's minus, what do I have here? I have 1 over 2 square root of x dx. Let me get rid of all this here. All right. Well, it is really convenient, just like with derivatives, it is convenient to rewrite this in a little more user-friendly form. When we do derivatives, remember, derivatives don't play well with radicals. You typically write this as x to the 1/2. Well, we're going to do the same thing here. Rewrite this in exponential form. Is it clear? I'm not going to do any computation here. This is just rewriting the problem. This is x to the 1/2 minus 1/2. And this is in the denominator, x to the 1/2. All right? All right? Again, derivatives and hence antiderivatives don't play well with variables, with exponents in numerator, or sorry, in denominator. So again, I'm going to rewrite. This is rewrite. So rewrite this, rewrite here, rewrite this, all God's children get rewritten. So, you may rewrite this in the numerator. Right? So what goes in the, this is 1/2. What goes in the numerator? The numerator is x to the 1/2. The denominator is 2. No calculus has transpired. You rewrite, rewrite. You rewrite this in a little more user-friendly form. Now, you're ready to hit it with a calculus stick. Power rule, power rule. Sorry, made a mistake. You see my mistake? My mistake is this is -1/2. When you move this to the numerator, it becomes -1/2. Now we're ready to hit it with a calculus stick. The power rule says add 1 to the exponent, divide by the new exponent. So this is x raised to the, you tell me, what's 1/2 plus 2/2? 3/2. Divide by 3/2. What's divide by 3/2 is multiplied by 2/3. Divide by 3/2, multiply by 2/3. I'm going to do that on the fly. You should get used to doing that on the fly here. All right? Minus, add 1 to the exponent. What's 1/2 plus 1? I'm sorry, -1/2 plus 1. -1/2 plus 2/2 is +1/2. There is already a 2 down here, so I'm going to do this. I'm going to write this 2 in blue so we can keep track of which one's which. Now, you divide by 1/2. Divide by 1/2. So actually there would be 1/2. But what's divide by 1/2 the same thing as multiply by reciprocal? Divide by 1/2 is the same thing as multiply by 2. So this 1/2, let's watch its little journey. It becomes times 1/2 here. That means multiply by the reciprocal. So that means multiply by 2 plus the constant. And I really hope it's not asking too much to cancel the 2's. So we have 2/3 x to the 3/2 minus x to the 1/2 plus constant. That takes a lot longer to explain than it does to actually do the process. The fractions can be a little dicey. Just write them in exponential form. Use the power rule. The radicals, rewrite the radicals without the radical. Rewrite the radicals in exponential form, and the integral goes much more smoothly. All right. Our next little item. What if we have 1 over t to the 4th plus 1 over t to the 3rd minus 1 over t to the 2nd dt? Derivatives don't play well with variables or with exponents in denominator in this format. So we're going to rewrite this without the fractions. X to the fourth in denominator is the same thing as t to the fourth in denominator is the same as t to the negative 4. 1 over t to the third is t to the negative 3 minus 1 over t squared is t to the negative 2. Note my parenthesis because I have several terms here. All right? Add 1 to the exponent. Negative 4 plus 1 is not negative 5. It's negative 3. So this is t to the negative 3 divided by negative 3. This is now same song, 2 more stanzas. Add 1 to the exponent, divide by the new exponent. Add 1 to the exponent, divide by the new exponent. That's good enough for me. You can simplify this a little bit. This negative cancels with that, but that's good enough. All right? If you check your answer in the text won't write this. The text will actually simplify this, just like the text will simplify this. So you could write this as plus t to the negative 1. Now, you may, if you wish, rewrite this. You may rewrite this as, all right, I'll move this back down. You may rewrite this. Put this negative out front, this negative goes out front. Let's do this. Negative 1 over 3 t to the second. This becomes negative 1 over 2 t to the second. This becomes positive 1 over t to the first. There, you may, if you wish, rewrite it. You haven't gotten it more correct, you've just rewritten it in a different form. If you want to make it look nice, there you go. If you think that's putting a tuxedo on a pig, then just leave it right here. But this is the antiderivative, which is all we're after. All right? All right, one more and then we'll set you free here. Let's do 4 times sine of x minus 6 times cosine of x. What's the antiderivative of sine? Now, this is the thing the students get a problem with. The derivative of sine is cosine. So the integral of cosine is sine. The others are the negatives. The derivative of sine is cosine. Integral of cosine is sine. This is the integral of sine. The integral of sine is negative cosine. If the answer is the cofunction, it's negative. If the answer is a cofunction, it's negative. Not the question. If the answer is a cofunction, it's negative. So this is, what do constant multipliers do? Multiply along. So the constant multiplier multiplies along. If the answer is a cofunction, it's negative. If the answer is a cofunction, it's negative. This is wrong. Wrong, wrong, wrong. What it's supposed to be is constant multiplier multiplies along. This is not negative 4 times the integral. This is 4 minus, I'm sorry, this is not 4 times the integral. This is 4 minus this value. So if you put the negative with the cosine, you must have parentheses to indicate this constant multiplier is multiplying along. The easier version, and what you'll get eventually used to doing, is this. Constant multiplier multiplies along. Integral of sine is negative cosine. Just throw the negative out front. Minus, what's the integral of cosine? Well, the answer is sine. It's not a cofunction, so it's not negative. If there's any question in your mind, take the derivative. You check the derivative of the answer, it should give you this original question. The derivative of this, derivative of cosine is negative sine, the negatives cancel, there's 4 times sine. The derivative of sine is cosine, there's negative 6 cosine. So you always take the derivative. You can always check an integral. By taking the derivative, you should get back to the original integrand. So that's our antiderivative, and we're out. All right. One more and we'll get out of Dodge here. Some of these you may need to rewrite. So if I have secant times tangent of x plus secant of x, there is no product rule for integrals. There is no quotient rule for integrals. There is no chain rule for integrals. There is no product rule for integrals. So the only way to do this is with something else. You cannot do integral of this product or something. It doesn't work that way. What you may do is rewrite this. First, rewrite. Distribute in secant. Erase this a little better down here. A little more vigorously. Secant tangent, that sounds familiar. Plus distribute secant squared, that sounds familiar. What I have written here is wrong. This is wrong, because this is two terms. It needs to have parenthesis around. All right? Now, the integral of the sum is the sum of the integrals. What's the integral of secant tangent? That's secant. How do we know? We can check ourselves. What's the derivative of secant? Secant tangent, that's correct. What's the antiderivative of secant squared? That's tangent of x. How do we know? Because the derivative of tangent is secant squared plus the constant. So, the integral of secant tangent is secant. The integral of secant squared is tangent. That sounds like blah, 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 blah. Eventually, this just is part of your mental furniture. You understand this just as easily as you know where your couch is in your living room. The antiderivative of secant tangent is secant. Antiderivative of secant squared is tangent. So that's our result. Now, the next video we're going to talk about how do you find this constant of integration? What kind of information do you need to have to find it? And once you have that information, what do you actually do to compute it?